Hello, class, and welcome to our next lesson. I wanted to continue our discussion on the refraction of waves. And in order to help us with two-dimensional and three-dimensional visualizations of refraction, I pulled up this simulation that I found. And how it works is let's pretend, I know it says here visible light, infrared, UV. But for our purposes, let's pretend that this is deep water and this is shallow water. And we know that the speed of water moves more slowly in shallower settings. We also know that its wavelength is going to change accordingly. Now, what I have here is I'm going to be sending off a ripple propagating at some angle that's not head on with the normal to the boundary. So let's hit play and see what happens. Okay, here's it propagating. I'm going to stop it for a second. It was propagating in this direction. Notice what happens. It came off at a different angle than it struck the boundary at, and the wavelength changed. This is the transmitted wave. Over here, though, is the reflected wave, and its wavelength is longer. This is moving more slowly. This is moving quicker, longer wavelength, shorter wavelength, same frequency. And I'll let it play, and we're gonna every so often we're just gonna send out a series of pulses. Here's our angle, and then it comes off a little bit. Um, you could call this at a greater angle than that which it hit with, and they come off as such. Okay, great. Now let's see the three-dimensional view. The three-dimensional view is going to show us what happens to the amplitude of the transmitted wave as it crosses the boundary. Lower amplitude, lower amplitude. It has this much energy as the source emanates the series of waves, but it hits the boundary, slows down, has a shorter wavelength, or reflected, maintains wavelength, maintains speed, comes off at the same angle that it hit the boundary at. Um, I think this is pretty helpful in making apparent what happens with waves as they cross a boundary. We see partial reflection, we see partial reflection, we see how the amplitude changes. So we know that there's an exchange of energy. The important thing to know about waves, remember, waves is one of the mechanisms through which energy can be transferred. The other would be the transfer of matter. Um, but if we were thinking about different devices that capture the intensity of distant waves, such as detectors that can see the light from distant stars, or even on our cell phones, we have microphones that can capture the sound of the environment. We have all these reflections, all of these refractions, transmissions going on. We're able to make predictions based off of what we know to be properties of waves and how they behave at boundaries. And While this is merely a simulation, it really does help to show us what realistically can happen. So, anyways, I hope this has been helpful. And until next time.